Hello everybody, I'm going to show you how to use Tokamak physics engine. It's a open source engine written in C++. You can use this engine in your games. So let's start. First of all, we need to download the library. So go to their website. Click this link and you can download the library from SourceForge. So click this link and here's the file. Just click on this. Okay, here's the file. You can press OK, but I'm going to click cancel because I have this one already. And the next thing is we need to download another library called SDL because we need to draw our objects on the screen, so it's a 3D environment. So I'm going to download this one to use with OpenGL. Okay, here I'm going to use this 1.1 version. Okay, we need to download development libraries, so I'm using Visual C++, so I need to download this one. Okay, again you can click OK, but I'm going to click cancel. Okay, now extract these zip files into a hard drive. So I have them inside, yeah, this one, SDL 1.2 and Tokamak. Okay, now actually okay, now let's open Visual Studio and create new project. Win32 console application, enter new name, press OK. Next, we need to empty project, so click empty project and finish. Okay, let's add a file, cpp file. I'm going to give a name as main. Okay, we need to include header files for those libraries. So for SDL we need to include sdl.h. For Tokamak we need to include tokamak.h. So the so we need to link tokamak.lib file, and from SDL we need to link those sdl.lib and sdl-main.lib files. Okay, so I'm going to set those directory paths. Click C and C++, click General, additionally include directories, add new entry, and go to those folders. Okay, add this path and again add new entry, go to the libraries and Tokamak include. Okay, now include paths are okay, and go to linker, click general, additional library directories, do the same, add new entry and go to the libraries. This time go to the lib folder and x86. Again for Tokamak, go to the lib folder and select folder. Okay. And go to input, additional dependencies. So here we are going to use OpenGL, so I'm adding OpenGL libraries, OpenGL 32.lib and GLU 32.lib and Tokamak.lib and SDL.lib and SDL main.lib. Okay, now project settings are okay. Let's include the necessary header files. First of all, we need to include windows.text, and then let's include GL headers. And then let's include SDL. And next we need to include Tokamak.h. Okay, just add the main function. Okay, let's see whether it's compiling. No, because yeah, SDL main reference function underscore. We need to undiff the main. Because that function is already in SDL main library. Okay, now compilation done, and we need to run this application. We need to give the runtime library of SDL. Go to SDL folder and lib folder x86, copy this DLL and go to your project location and paste the file here with this exe file, so we don't get any errors from runtime. Okay, now okay, then let's okay, let's create let's initialize SDL. We need to call this global functions SDL init. we need to pass the flag here. I'm going to pass SDL init everything. And we need to clean up the memory by calling SDL quit. Okay, now syntax highlighting also working. And next, and the next thing is we need to create the window. Here is the window width and window height and bits, pixel depth, and OpenGL flag. Okay, this will create the window. We can try by running. Okay, and then we need to create the main loop. To event object. And we need to filter out the event. There are a lot of events. I'm going to check the type. When we click the close button on SDL window, it will create a SDL quit event. I'm going to catch it. Okay, if this comes, I'm going to actually we can't break it here, so let's add a new variable. Okay, now it will break the while loop properly. Yeah, I don't want any other events, so I'm done with the events. And next thing is to after the events we will update the physics engine, and then we will draw the objects, and after that we need to swap our buffers, basically front buffer and back buffer concept is there, and just add small delay. Okay, let's build and run. No errors. Okay, you can see here the window. Okay, now okay, next thing is to initialize OpenGL. So I'm going to initialize OpenGL here. We need to set up the viewport and our camera frustum. Projection, reset the matrix, projection matrix, and we can use this helper function to create a frustum. This is our Windows aspect ratio. And then near clip distance, let's set 1, and then far clip distance. Okay, we are done with the projection matrix. So let's load the GL model view matrix, reset that matrix, and we are done. And again we need to enable GL dip test. Because we are working with the 3D objects, and yeah, that's fine. Let's build and try to run. Okay, it should not give any errors. Okay, good. Then let's move to the our actual tutorial topic, so the Tokamak physics engine. And you can go to the documentation of that library, go to that downloaded folder and go to documentation folder, and inside that folder create index.html. so here you can see the very simple documentation, and it has only few classes and structures, so it should not be that hard. So the main class is any simulator, and here there is a static function to create a simulator and also to destroy simulator. So let's create that simulator. Okay, I'm creating a global variable in this simulator. Okay, we have global pointer to the simulator, and let's create that one. Okay, there are few arguments that we need to pass. First one is size info, and next one is allocator function. The last one is the gravity. So we need to create few variables. Gravity vector should point to the downwards, and default size info is enough for this tutorial, so I'm just going to pass them. Try to build. Okay, cannot convert parameter 3 from. Okay, we need to pass the address here. Okay, all are good, and let's delete our simulator object. Okay, and actually I am going to simulate the falling cube onto the ground, so let's create some variables to hold those objects. Okay, this rigid body is controlled by the physics engine, and the animated body is controlled by the application. It doesn't move these animated bodies, so actually the flow shouldn't move, so I declare this as it as a animated body. So let's create those objects. I'm going to add 1 meter width and 1 meter height, and 1 meter depth cube. We need to calculate the inertia. We need to pass box size and the mass. Box size is already added here, so I'm going to copy, and let's add mass as 2 kilogram. And also we need to set the mass here. Okay, and we need to set initial position. Let's add the position above the center position. 7 meter height is enough. Okay, and set position. Okay, and then create the ground. Actually, for the flow also we need to set cube shape, not the cube shape, the box shape. Width, and we need to set a small height. Okay, and we need to set position, initial position. Let's add it to the center position. Okay, now we need to update the physics engine. Let's add some small time. We can set this later. And the second thing is we need to draw the flow and the cube, so we can see it in our virtual world. Now the world is empty, so I am going to add a new function to draw those objects. Here we need to clear our buffers. Reset the matrix, and here we need to draw the cube, and then we need to draw the flow. And we need to call this function here. Okay. For this first of all we need to set the camera position. We can use the GLU look at helper function. So I am going to set I coordinate as some far location, and target position as center point. And camera vector should be y axis. Okay, camera is okay. Now we need to transform those objects according to the Tokamak physics engine, so we need to get those transformations. And we need to convert those transformation to OpenGL matrix format. So I'm going to write that conversion now. We need to set rotation matrix info. next we need to get the position. Okay, now the transform matrix is okay. Now we need to pass it to OpenGL, so we can use GL multi-matrix function. Okay, now we need to draw the cube. Okay, actually I am going to copy the render cube function somewhere else, because there is no point rewriting this code again. You can pause the video and you can write it down. Okay, and I'm going to call that function here. Our cube size is 1 meter long. Okay, and also I'm going to copy that flow drawing code. Okay, and next thing is to draw the flow. Actually we need to do the same thing. But instead of cube we need to get transformation from flow, and we can call draw flow function. Side length is 10 meters long. Okay, since we are drawing two objects that has two different transformation, we need to manage the OpenGL matrix stack properly. So I am going to use some functions here. To readability, I am going to add some braces here. Okay, and also because of that we need to we can recreate the variables with the same name, and I'm going to copy this here also. Okay, let's try to compile. Compilation is success. Okay, now you can see the workings of the physics engine. okay, thank you.